Hello again. I seem to have returned. Okay. I was just setting everything up and it seems to be working. Very nice. Avatars here, programs here. Hello. I see the group is already here. That's very nice. My laptop's still starting. He's a bit late to the party. My school stuff is on him, so sometimes I need access. That guy. Now he's good. Very nice. Buy a little turtle. Yes, you do. Sometimes I'm up here, sometimes I'm down here, but I'm here again. Hello. Don't know why starting a stream always confuses me. Till I find my bearings and get into the flow. Okay. Oh. Yes, that looks good. Okay. Oh, I'm gonna jump right into it. Just a little recap from last time. I'll just open my hardware. The hardware that is projected inside of the software. See, of that stuff. Oh. My aim is bad today. My mouse aim is bad. Okay. For context for everyone, I'm working on a crane, automated crane storage. I have changed my title to reflect that because I heard that semester project is a little bit uninteresting for some people. The hardware in question you can see on the top right. It's the crane model that's mentioned is the red guy. He has a free axis, he can move forwards and backwards, up and down, left and right. And we try to automate that he can take out and put in blocks inside the little storage area. I have removed the storage area in a previous stream because when I'm during the setup phase, I don't want him to crash into the storage bay. We'll see that storage bay later in later streams than when I can actually test him with the little aluminum blocks I have right here on my desk. To the right of the crane model is the electric motor that I will have to connect to one of the axes of the crane. It's just a little add-on from the teacher. So to make it a little bit more complicated because it is the end of semester project I have to do. Last time we left off with an error. This guy right here is the motor controller. He said he lost connection to the central unit, but now after a restart he seems to have fixed himself again. He in general is a little bit when I did the hardware setup, which I did before I started streaming this whole project, he took me like around 7 hours to set up, just to get him into a state where he would connect with everything else. I'm programming this on a Siemens industrial controller. I have him here on my desk, which sadly I don't have a camera for yet. I'm planning to add one that shows that, so you guys can see the controller plus the little touch panel I have here, which will be programmed later on in the project. So now the pink guy is the one that's connected through the pink line is the crane model, which is the focus for now. So you can kind of forget these two, we'll get to them later, because just the controller and the crane model are the focus. I want to get them running first because then I have most of the logic already programmed, and I can just add the little bits I have to do with these guys into the mix. Okay. For planning, I use a tool called OFT2, Omegon Fluid Technology, to make graphs that reflect what the program does. This is my overview that I use to measure the progress. The wait step obviously is the first step, and the program will stay in that as long as there is no user input. After that, we move down. We want to, if the user put inputs, I want to take out this block. We move to that position. We in a previous stream I have made a function that I can reuse to position every axis in its corresponding location. Then we have to do a load instruction. So the arm extends, picks up the block and returns outside of the storage bay again. Then we need to position it at a new location where we want to drop off the block, and we have to actually unload him. These four steps, I just noticed I have 2 steps free for some reason. Seems like my counting is a bit off. 4, and you are 5. So these four blocks are I have done in the previous days, and now I'll try to make the unload block, the code that unloads the block. We are programming this in TIA Portal, which is the programming suite for Siemens. I'm working on a system that magnifies the text here on the left side, because I think that is somewhat important, but that sadly hasn't finished yet because I didn't have enough time invested there. But I keep working on it, and at some point when it's ready I'll show it off. Oh, we will be mostly working code, so I'll hop back over here and let's see. Let's open our main code. In TIA Portal, everything is grouped into blocks. They are used for repeating code and also for organizing the structure. Just how you would structure a normal program to multiple files. Here you have multiple blocks. I can make the text on the left there, but I can make the blocks bigger. I think 150% should be enough. Anyone wants any bigger magnification, just tell me. At some point I just have to say stop because I can't read anything anymore. Now we also have, which wasn't shown in the graph before, we have a manual mode this one is just so I can move the crane model by hand if he gets into an uncomfortable position, let's say like that. Right below we have a function block that's called encoders. To know where we are, we have to measure the rotations of the electric motors, and those so-called increments will get fed into this block, and we can count them, and so we know how far away we are from our start position. Then below that we have our function block loading. This guy will in the end be encapsulated into a block that is called automatic mode. But for now he is standalone here until we have written the whole automatic mode. Now let's create now for what we want to do today, the new unload block. We make a new function block. I think I made, yes, loading is a function block, not a function. In TIA Portal, there is a slight difference between a function block and a function, insofar that a function doesn't have a memory by itself. So you call it, and after it finishes its execution, it stops executing, obviously, and then it forgets everything that was fed into it. You still get your result, but the function does. But if you then call the function again, it starts fresh. In contrast, the function block, the blue one, has a memory. So you can call it, give it values, it gives you the result, and if you call it later on again, it remembers some of the previous values you gave it. Everything has its uses. I mostly use functions for recurring code and function blocks for organizational code, but they are interchangeable to one another. Depends on your programming style. I called the other one function block loading, so I'll call this one function block unloading, just to stay a bit consistent. And now he gets created. There he is. We start empty. As with everything, we need to define we have an in and output section where we need to define our inputs and outputs from this block, because the block itself is treated like a black box. You feed it something, you get something out. So we need to define what we need to feed him and what he will spit out at the end. I just open my loading block because the unloading block is basically the loading block in reverse. I can't just copy it because just reversing code is not just copying it and rearranging everything. It sadly is not that easy. But I can take the in and outputs because they should essentially be the same. But we'll see. Let's take a look. Okay. What I will do now is I can split my view like this. It's very helpful when I'm dealing with code that is similar to something else, so I can peek a bit, make some peekaboo. Scale you up so it's a bit more readable. You too. Okay, now this is my convenience. I'll put in the title of the block up here. Now, what did we do in our loading block? We Ah yes, we initialized the program counter. I think that guy we can just take over one to one. Wouldn't be much of a difference in that. The program counter, for context, everything in the function block itself needs to be done in a certain order, and to guarantee that it does that, you want to have like a counter that increments after every instructions. So the instructions not only get triggered by a certain variable, but also by the program counter. So if some program part of the program listens for the same variable as another part, it doesn't get triggered because it will have a different counter program counter value that it waits for. I would like to have that the same. I initialize it to 2. So when we start our function block, the program counter will be 2. And the reason for that, I'll show real quick. There is another graph for that. I have my loading graph. I made one for every it's good practice to do a graph like this for every part of the code, not for the whole code itself. That would be way too big. But as we can see, these steps all are numbered as well. So what we would like to do makes it a bit easier to compare the graph to the code. You want to have the steps be the same number as the program counter. So when the program counter is 2, we are in step 2 over here. Just for consistency. And the same I would like to do for the unload block. Not actually sure how much I will have to change. It should be pretty consistent, because for the unloading we also will need to move first to a new position. So let's copy that one over. We'll be lightning fast at this rate. Now what this code does is this condition here checks for the program counter. If the program counter is 2 and we are in position, the in position variable is on our input list up here. It will be set by the program by another part of the program that is responsible for positioning the x and z axis, which are forwards, backwards, up and down respectively. And so this block only will need to worry about the y-axis, which is left and right, so into the storage and out of the storage, and a little bit z-axis. I'll show that off when we get there. So first things first, we want to move the horizontal axis. I do that a bit. My naming will be a bit generalized because I would like to, because if I reuse that block for something like a semester project next semester or something, then I would like it to be, then I would like not to have the need to rename everything. It's enough work as it is. Yes. So if the program counter is true and the in position variable is set, we start moving the horizontal axis, which is the y-axis. And the end, as I said, these blocks are black boxes, so we just feed it stuff and we get our motor outputs, plus when he is finished we can write that into an internal variable that we can carry over. And I actually just noticed I gave that not a generalized name. horizontal. We are horizontally in position. So we just copy this variable over to. I'm doing it one by one so I don't copy over stuff that we don't need, which will make it, which would bloat the program. And we don't want that. Let's see. We also need motor plus, which is this one. Let's Q over here. And the negative motor, which is over here. Positive and negative just refers to the direction of driving. So plus is forward and minus is backwards. And since this is a function block and not a function, we need to give it a memory. Which is, where is that? Where did you put yourself? Oh, you are here. I would like you to be up top. I'd like to categorize it like that. Put you in here. Very nice. Just notice something. I made a mistake. Made a mistake over here. Now, I said earlier, if these blocks, they can remember stuff. And so if you have two blocks that have the same data attached to them, they can read each other's data. And that isn't very desirable most of the time. Yeah, I would like to not have that, because that can lead to very weird bugs. So I'll rename him. What are we doing in this network here? We are moving the horizontal axis forward, which we can abbreviate as extend. Positioning extend, yes. Now we make a copy of that data block, and now we have two data blocks. Data block extend and data block retract. Yes, extend. Extend and retract. Every extension needs a retraction, Groby. You cannot extend forever. Okay. What else do we need? Those red underlines under the variables means they don't exist. So I actually know what to take over and what not. X in horizontal. And we need to have this little trigger data block as well, which is this guy. Let's put you right under U. And that's just, and I also need to take over these two new data blocks I created, so we don't repeat the same mistake over here. And let's assign the extend one to this guy. Very nice. Okay, now let's continue in network free. Network free. Network free is vertical axis move up. Now, if you imagine the crane itself, the crane needs to extend into the storage area and then lift something up and then retract out of it. That's for picking up something. Now, if we want to put something into the storage, we want to extend, lower ourselves, and retract back out. So I am not sure This is one of the differences. I think we can copy it. We just need to fiddle with some of the position values a bit. Let's see. I make it big once again. Come on, is it Shift Alt F12? That's my keyboard combination. Very good. What are we doing here? We are checking the program counter, obviously, and if it is equal to 3, we trigger something. What are we triggering? We are triggering the calculate overlift. The overlift is that little lifting or lowering action we do after the extension. I called it overlift because it's a literal translation from the German word. It's Überhub for a German audience. I think my audience is very German right now. Very German speaking. Okay, we trigger this calculation because this calculation only needs to be done once. And everything inside an industrial controller is contained in an infinite program loop. Let's see, we trigger the calculation, and so we get a value out of that, which is a position. Yes, we take the overlift value and the current horizontal position and calculate the overlift position out of that. Okay. And we feed that into our positioning block. Now, this is a positive value. Because I don't want to have 2 fields for the overlift. I want to have 1 field to enter that, so it will be a positive number. Users don't like it if they have to input negative numbers, especially if they are the same. So what we could do, is there something? Let's look inside the overlift calculator. He isn't big, but it's easier to reuse him this way. I can actually scale that to 200%. Nice. We convert our integer to a double integer, and then we add that together. So that means if the overlift value is a negative number, the addition would turn into a subtraction. Because if you add a negative number, it subtracts. Math. Not quick math, but math. So I would need to I cannot edit the overlift function itself because I'm using that guy in other parts of my program, but what I can do is I can do stuff with the overlift variable I have in my unload. Let's see, what are my math functions doing? Can I just... Is there a function that will just turn it from a positive to a negative? Is there something that just does that? I have an addition, subtraction, multiplication, division, modulo, neg function. What are you? I've never used that one. A neg function. Let's see, there is a built-in help system that has info on everything. If you master this one, you can do basically everything. What are you doing? With the instruction neg, you can switch the value on the input in, and you look up the out value. What? I'm translating that from German because my TIA portal is in German. If, for example, you have a positive value on the input, then on the output there will be its equivalent negative value. So this just switches around. It will output 0 if one of the following happens. The enable pin is 0, which we won't do, so that won't happen. The result is outside of the range of the data type. Roby's partying. Are you excited about the help we receive from TIA Portal? Or it's an invalid value. Well, none of that we will have probably, so that's actually exactly what we need. Very good. So that means we just take our normal overlift variable, put it on the input, and then make a temporary variable that's called overlift neg or negated, and this needs to be also an integer, and that should do it actually. Yes, that should do it. We'll see when we get to testing. But I'm confident. I'm confident in my code. TIA Portal. Don't insult the TIA. Don't insult the Siemens gods. They will smite you with bugs. And since Siemens is also used to control facility building automation, maybe your sun visor will stop working. Who knows? Where I work, all the lighting is controlled by Siemens controller. Let's see. Let's split my screen again, so we can copy some more. Let's steal some code from my past self. Let's go. We need the overlift, the position overlift. Yes, we want that. We also want this trigger for the addition. Yes. Put you. Let's put you up here because all of the other triggers are up here. Nice. Something else that is red. Lifted. Lifted is red. The output of step 2. Let's put you in. Nice. But let's rename that because we aren't lifting anymore. We are lowering. Lowered. We are lowered now. Good. Now we need another trigger. At some point you have so many functions you can just copy paste everything. Good. which is nice and boring at the same time. Now we need to move backwards. Now we have lowered, the block is standing in the storage, and we need to pull ourselves out of it. The variable lifted that is used here doesn't exist anymore and is replaced by the variable called lowered. And I would like to rename our output variable to unloaded. I need to switch that up over here to unloaded. Very nice. Okay. Much better. And let's copy the next, the trigger again. That's like standard procedure now. Every step needs a trigger, so it only fires once. Okay. And that should be it. Didn't have to change as much as I thought I need to. I thought it would be worse. Seems like I'm understanding my own code still. Very good. Let's close that and let's close that. And let's go back to our main program. Let's throw you out because I would like to organize that stuff a bit. And let's create a new function block. Function block. We called our manual mode. It's function manual mode. Yes. And we want the function for automatic mode. You want the function block, so we have a memory attached, and that is automatic mode. And in here we will put this graph. Here we will combine all the positioning and loading and stuff. Oh, that's the help. Oh, I don't need that anymore. So what do we have? We have loading, let's do an instance. When I do an instance, I basically integrate the function block that's attached to the loading code. I'll attach that into the data block of my automatic mode code block. You are doing Unity. Oh no, my condolences. And so in network 1 we will put the position code. In network 2 we have the loading code. In network 3 we have another positioning. And in network 4 we will do the unloading. And we also integrate unloading. Don't need to write that twice and put you in here. Nice. And after that we should be finished. I'll also add another network up here because I will do another program counter that is separate to this code here. Like the blocks themselves have internal counters, and this block will also have a counter. So they're like nested counters. Let's see how that works out in the end. We'll see. We don't need that one anymore. Okay. Just cleaning up some stuff. Okay. Now, let's see. We need to position our axes. I have made a function block for that already. Or is that still the one? Target position, current position. Oh yes, that's the one that can only do one axis. So we need to make one that can do all three axes at once. Well, technically only two axes. We don't need to move left and right when we go to a new location. We only need to go forwards, backwards, and up and down. Okay. So this one doesn't help right now because this one can only control one axis at a time, and that's not very helpful. Let's drink, stay hydrated. I wonder if my mic picks up my drinking because I don't see the mouth of my avatar moving. Like everything's still working, just checked on the Twitch itself, seems good. Okay. Okay. Let's do the program counter first, and then we will do the... Now let's do the positioning first. Let's solve that. I would like a new function block. FB... What did I call the other one? FB positioning. I just called that one. FB positioning 2 axis, because you can do 2 axes at once. I'm not sure if I'm naming stuff in a good way, but I'm naming it different names, so I'm not too worried. And this guy will only consist of 2 positioning. Now the great question is, in the loading block we had a horizontal and a vertical axis, but now it's still a horizontal and a vertical axis. Horizontal, because forwards backwards is horizontal as well. Horizontal axis. Because horizontal. Positioning horizontal. Good. And we need that 2 times. This will be vertical. And for the network names, don't need to name that. You can just read this and it's clear what it does. Now for these guys, I make them bigger. So Groby, what are you doing in Unity? Are you editing your avatar? I'd like to steal some variables from my loading block, and specifically these 2, which are the motor variables, because they are essentially always the same. Motor plus for horizontal and motor plus for vertical and motor plus for horizontal and vertical. I will have to go through it and maybe rename some things to make it more easily reusable. Because that's what I was talking about with reusing stuff. So naming it not too specific names, but yeah. Okay. Now we have our motor outputs. We do need some inputs though. I'll just call the start variable start as well, because why not? Why the heck not? Can I copy? Can I steal some more? Yes, I can. Can steal these. Current position, horizontal, current position, vertical. I need the stopping tolerance. Don't need the overlift. So, yoink. But I will need to put in some more variables for positioning, because target position horizontal, and let's copy that and make target position vertical too. Here we at least just need one target position, because we will only be, yeah, we don't need target position negative, because we will drive forwards or backwards until we reach the position value. We have our current position on the horizontal axis, our current position on the vertical axis, which we calculate in the function block encoders, and we have our stopping tolerance. Perfect. Now let's assign that stuff. Start can start both of them, because I would like to move efficiently, for the sole reason that the motors on this crane model are very slow. I have a horizontal target position, and the top one is the horizontal, so target position here, target position vertical here, current position horizontal here, vertical down here, and the stopping tolerance will be the same for both, because everything's using the same motor, the same encoder, everything. Okay, and that should already be mostly it. We just need another network, because we are only giving out the finished x. Our output variable will be called x in pos, just like the one in the other block, haha. But we will only output that if both axes are in position, because before that we aren't in position. And that's pretty easy to do. We just take an AND. An AND is only true on the output if both inputs are true. We just make, so we want to make temporary variables. I'll put them in, I'll make them non-temporary for now. Let's see. I'm worried about them not resetting and causing bugs, but I can always make them temporary if it leads to issues. X in pos horizontal. Let's keep with the naming scheme. This is not, this is the wrong data, we need a boolean. X in pos vertical, nice. Horizontal goes here, no, horizontal goes up here, this is the horizontal one, this is the vertical one, and we just plug them, also plug them in here. Very good. Very nice. And once both of those output a 1, so both of those blocks have finished their task, the output variable in position will be set, and so our program will be able to continue. Let's go back into the automatic mode and just pull in, where is he? Positioning to axis. Let's instance that in here, but we will have multiples of new. We need to position multiple times, and I would like them not sharing the data. Positioning to axis. I think it's step 2. Yes, it's step 2. Step 2 here in the graph, so I just call the data block step 2. Okay. And now we pull him in a second time and call A. Want to instance you, and you are also in step 4, so step 4 it is. There he goes. Very good. So that's pretty much everything. Why are you red? Where did the function block for loading go? Oh, I should not delete that. Did I delete it? Damn, I have fast fingers today. Let's recreate you. Can I recreate you? Yes, make an instance, multi-instance, and let's recreate him like that. Move him up, nice. Now everything's in. Why is there the function block that's called positioning? That should not be here. Only be the 2-axis one we have here. Maybe it's one that I pulled in earlier. Let's just delete it. If something gets red, we'll see. Once I compile it, it'll throw errors if something's missing. Okay, now let's do the program counter. For that, we may steal some code again. As I said, much copy pasting. This is the counter from my loading function. Put you in here. You will create my counter, and this logic here is for. Oh god, I'm copy pasting on the wrong place. Let's put you here. Gone. That variable doesn't exist over here. I have put you into my main block, where you should be. You need to go in here and delete you out of this one. Okay. Little confusion on my part. Well, too bad, happens. Okay. Do we need to still initialize it to 2? No, we do not. this one starts at, oh no, we do, it starts at 2, 2. God. And we have, isn't this maximum steps plus 1? So we have 5, so it should be 6. Yes. I should switch that around because this one is bad. I'm just checking if it equals to 5, but if it gets executed one too many times, it'll be 6. So this one will never be true, and that would be a bug. If you are greater, no, it's this one. I'm always confused by these operators. If this guy is greater than this guy, yeah, so I can just put 4 in here now. That's much better. Now I can actually put the number of steps, not the number of steps plus 1 in there, which is also less confusing for me. So here I have 5, and I switch that to this as well. Very good. And you just check for the equal, because this one needs to only to work when it is equal. Let's just copy that to every program step. Nice. And that should be, oh, I forgot the variables. Where are you? Get over here. Program counter. Static variables, and you go in here. And that should remove all the red curly lines. Yes. Now it's only, now the program's only mad because I have not populated all of the in and outputs with variables. Okay. Okay. Next. We need to have current position values and target position values. The target position values will in the end be provided by a user over a graphical interface that I'll program on the touch screen that's sitting right next to me. But for now, we will probably just have a global variable that we manually control from inside, to manually override in here in the TIA portal. You can force variables to have a certain value, so I'll probably just use that for testing purposes. Yes. Okay. But what we can do is we can pump in our current values because they already exist. We can also, I think I have named some here. Yes, here, current. I'll just copy them out, modify it a bit. Inputs. Now, since this function block here, the automatic mode block, is mostly for organization, I will get a little bit more specific with the variables here. So this is the current position x-axis. And I said x and wrote y-axis. Very nice. Current position y-axis. And now I make one more copy. And it is z-axis, z-axis. I'm trying to use the British version because I don't like that the third letter in the alphabet sounds the same as the last letter in the alphabet. But it's just harder to say. Way. Now for the positioning, we want to put the x-axis as our horizontal axis and the y-axis as our vertical axis. Oh yeah, we also need the stopping tolerance. I think, yes, I named that guy here. I can just copy that because I won't rename them. That one. You are my stopping tolerance. Good. Same goes for the other positioning block. You have an x-axis for horizontal, a y-axis for vertical, and a stopping tolerance. Now our loading block will have as a horizontal and vertical axis too. The horizontal, oh wait, I just noticed a mistake. The vertical axis is the z-axis. Z-axis goes up and down. Yes, that makes way more sense like that. Okay. On the loading block, our horizontal axis will be y. Tell me why. And our vertical axis will be the z-axis. The vertical is always the vertical one because it's the only vertical one. And we will need the overlift value too. Let's copy that variable out of here as well. Okay. And our unloading one will be populated the same way. Z-axis, string tolerance, and overlift. Wait. No, they are the same. I was confused for a second. Like, did the other guy have a stopping tolerance? No, loading and unloading have a stopping tolerance. We always need that. Because the encoders have so small, often the counter is so precise that you can never reach an equilibrium if you don't have a tolerance. If you just drive for one value, you will never stop because it will always over or undershoot. Okay. What I want to do over here, I have a group down here of those code blocks that are just functions. So the stuff I plan to reuse, and since the function block positioning is more used multiple times, I'll put him as a function into this little folder. So it doesn't clutter up my program organization blocks up here. Manual control is also more a function than an organization one. Manual mode, automatic mode, encoders, loading, positioning, 2-axis. I'll leave them up here for now, but they probably will wander into a folder at some point as well. We'll see. There's always something to do. Now we have all our inputs and we will need our outputs. For that, I go in my loading block again and copy some more. I'll copy the motor variables this time. Because even in here, the motors are the same. I just rename it a bit. This is motor plus on the x-axis. Motor plus on the y-axis. I forgot character. Okay, and we'll copy that once more because now we have 3 axes and this will be our z-axis. And the backwards variables will get the exact same treatment. X-axis, y-axis, and copy you, and our z-axis, the favorite one to say. Why are you integers? Oh? Why are you integer? What? What have I done? Oh, I'm confused now. Why? Why are? Why? Why? Motor plus, motor minus. Oh, I probably made a mistake somewhere. They are? Where are the outputs? Here are the outputs. Oh, I know why. Yeah, yeah. I grouped the variables themselves into something that's called a struct. But on the when you have in and outputs, you can't use structs because it'll display it can't handle it basically. So I need to take them out of those structs and then delete the structs. Okay, now let's see what got read. Horizontal, horizontal, yeah, all of them got read. Too bad. Is the same true in the positioning thing as well? Did I? No, I don't have a struct here. Yeah, it just doesn't work. It shows the title of the struct in the interface here, but it doesn't let you access the underlying variable. So it's just confused. Yeah, that looks much better. Now we need to update both of those and also update the data blocks. So everything, yeah, now everything is black again. Good. Now we can, oh, I also need to delete these because I have copied them out. No structs in my in and outputs, please. Or I'll have problems with addressing variables. It would be really nice if that worked, but Siemens says no. Some more hydration. Okay. Damn, it's already an hour. Okay, come on. Horizontal is my x-axis. Oh, now it's very weirdly arranged. This triggers me now. How dare it to trigger me. I would like to have you up here. The interface on the block itself will mirror the exact order you have it in here. And I grouped it weirdly now that it's not in a struct anymore. And that annoys me. Horizontal, horizontal, vertical, vertical. That's much better. That's much better. Okay. Did I do the same here? Horizontal, horizontal, vertical, vertical. Horizontal, yeah, that's much better. That works. Okay. Let's do the outputs. Now that we have, let's say, most of the output variables, at least the one we have to pull to the outside, we can start to combine them. You don't want to put them just in here, because they will start to overwrite each other. So basically, like the two, for example, the two positioning, function block positioning two axes. This guy and this guy have exactly the same outputs. So if, let's say, this guy writes his output value into the mod plus x-axis, and he will keep it negative down here, so 0. This one is 0 and this one is 1, then the output will be 0 because the program is stepped through from top to bottom. So it reaches this part, variable will be set to 1. Reaches this part, variable will be reset to 0. So that doesn't work, so we need to use a little trick. We just take an output block and an OR gate. If any variable is true, the output will be set to true. So our mod plus x-axis, like this, and we need to copy that 6 times. 2, 3, 4, 5, 6. URY, URZ, nope, XZ. I don't have combined axes. This will be the negative one. Oh God, get me over here. You will be the negative y-axis, and you will be the negative z-axis. Okay. So we just need some temporary variables to connect all of these with their respective outputs over here. So we have x, let's call it mod plus what would be an intelligent name for that? X-axis 1? That's not very telling. Let's call it for the step number, step 2. It's the x-axis in step 2. Yes. I think that's not too bad. Let's make the same axis again, but for our negative value, and TOPortal always increments the number if it is on the last position. Good, and I will need the same for the z-axis. Also in step 2, z-axis, but you are the positive one, and down here we'll do the negative z-axis. And you're my vertical axis here. Come on. Okay. Now we can put those here. Plus x-axis minus, oops, that's the y-axis. I'm confusing myself again. I'm confused by my own structure again. Ah, why? Why, turtle? Why? Tell me why. Pause, turtle. Why is my past self the most stupid but most intelligent person I know? Why? Okay. Now that should work. Why are you gay? I am not gay. You are gay. You are gay. Ah yes, peak content calling the viewers gay. That's peak. That's peak. Now we also have the z-axis here, but we need to make new variables for that. Let's make some y-axis variables. This is step 3. Positioning is step 2. Loading is step 3. Yes, so it will be step 3. And so we need a y. You will need to be positive. You are also step 3 and you are a y-axis. This will be very confusing. Horizontal is y-axis. Horizontal is y-axis. Vertical is... You know what? I can make structs in the temporary variable. I think I'll group them to the step they belong. So you guys... I want not pull it. Okay, select. Oh, you need to be a struct. Step 2. Here. Did that? No, of course it doesn't. It would be too easy if your portal reassigns it automatically. Let's do it like that. And let's do the same down here. Oh god. What's going on? Help. Okay. Same for, let's put these ones in here as well. Put them down here. Reassign. Assign you and reassign you. Now let's make another struct. Step 3. And we can put these guys in here. That should make it way less confusing. Okay. Now for my vertical axis, it's the z-axis again. The positive one first and the negative one following. Step 3. Get in there. Very nice. Y, Z, Z, Z. Very good. Now, step 4. Step 4 needs this basically the same setup as step 2, so I copy that. I will need to rename them, otherwise it's pretty useless. You are step 4, you are step 4, you are step 4, and you. Assign you here, assign you here. That's why I do it in this order, so I can just pull them out like that. And again, unloading needs the same setup as step 3, but is step 5. No, not step 4, step 3. Let's copy all of you and put you in here. And just rename that to step 5. Very good. No selection. I would like to pull out. Sounds wrong. Okay. And that's all up here. Now let's put everything in here. Okay. Step 2 I already did. Step 3 is y-axis, positive, negative, and one more on the z-axis, z-axis. So good. Now step 4 is the x-axis. X-axis, it's jumping around again. Negative x-axis, and I'll need to make one more of these. Z-axis and z-axis. And step 5 adds to the y-axis like this, and again to the z-axis. The z-axis is used a lot, basically used in every step. Okay, now this will just combine everything into these outputs and not override, and they won't override each other. Good. Now this, oh, I still need to change the programming counter value. You are number 3, you are number 4, and you are number 5. And this one will be executed every cycle, program cycle. Now we need to do the variables that not only the program counter triggers the function block, but also the variables here. So let's create them. I'll do them as static ones. I'll just call them the same as before. X in pos, which needs to be not an unsigned integer, but a boolean. A boolean, like this. Yes. Then you have as output the loaded. Put you here. Why are you jumping like that? How dare it to do that? You are a Right. I have 2 in position variables. Let's just call you loading. It's the position value for loading, and this will be the position value for unloading. Yeah, that should work. Unloading, and that triggers this guy, and if he finishes, he is unloaded. I'm not sure what I will do with this one, but it will probably be like a reset. A reset or something. We'll see. This one doesn't have, oh yeah, this one needs to be our physical input. Needs to be a physical input. X start. Like this. Nice. Now everything should be good. There's a little icon here if something is isn't good. So everything is good now. Only thing we are missing are the target positions. I can put them in. I could actually put them in. Make 4 empty slots. See. We need technically I only need 3 target positions. Or do I? Now the question is, do I input target positions according to axis, or do I input them according to what the axis does? Like the function of it. So will I have an input value for loading and unloading, or will I have just an input value for the y-axis? Which is the question now. Target position. I think it's easier if I group it according to what the value should do. So I have an integer. Oh, you guys all have wrong names. Stop having wrong names. That's much better. I'm using Hungarian notation for my variables, which just adds one character at the start of the variable name to denote the variable, the data type the variable is, and n is an integer or a double integer. It's everything that is an integer. So I need an integer for my loading position. Yes, and I need that for the x-axis. I need to categorize for both, I think, because I need one for the x and the z-axis. You are a double integer because you can be a big number. Loading position. Yes, yes. And then I also need one for the unloading position, so I can just double that. Bye, Groby. Have fun in VR. Don't gorp too hard. Unloading and unloading. And the unloading will be done here. Unloading block. Loading the loading block from storage. I'll give these names now because I'm getting confused. Moving to unloading position. Let's copy that up here to loading position. Loading block from storage, and down here it's unloading block from storage. And this is just write internal variables to outputs. Yes. No. Okay. Now, yes, I wanted to put, oh, I already did, unloading variables. And what do we need? The target positions for loading the block, so for the y-axis. Let's just call that extended in honor of Groby, extended y-axis, and on the contrary it will be retracted y. Target plus, target minus. And I don't need to input anything for the z-axis because I'm actually calculating the overlift from the actual position of the z-axis. And this guy will actually use the same target positions, which should be everything. Now everything should be populated here. Yes. let's look at our this will be pretty big block. Let's see. Pull him in. Rename that. Automatic mode. How big is it? Yeah, it's pretty tall. Not too bad. Yes, I have made some variables here for motors already that I can reuse, but I will also need to rename them. But that's no biggie. This is motor X plus, oh, I just wanted to copy you. Copy you here, copy you. Is this the y-axis? Oh god, there, oh god, I have not changed that. I need to change that, it triggers me. Everything needs to be uniform. My OCD doesn't like that. My perfectionism. Okay, that's much better. Let's get out again and refresh you. Thank you. I like that much more. Let's try it again. Mod X plus, mod X minus, Y plus, Y minus, Z plus, Z minus. Okay. Now let's rename them because they're still named after the loading block I had in here before. Also need to have you automatic motor. X automatic mod X. You know what? I can copy this block of text. Now I just rename everything so it's consistent again and makes sense. Because I made these variables to test the loading block, if it would actually do something. It didn't really work yet because I will also need to make a zeroing of the to automatically zero out the encoders. That's what I wanted to say. Good. And this block does exactly the same as the other one. It just takes the internal variables and writes it into the physical output. So now let's see. We have our loading and our unloading. That's good. Close you. Yes, I would like to save. Now, wait isn't really something that you program here, so that's good. We have positioning, we have loading, we have positioning again, and we have unloading. Perfect. So that's pretty much done. Something we still need to do now is the model needs to know where it is, because the missile needs to know where it is. So we have to program some code that lets him do that. For that, we need to make another block. But now we make a special one. We make OB100. Now, I think I have to explain that real quick. This is my school stuff here. It's a PDF. Let's go to the whoop to up here. Let's see. Where are they? Where are they? Where are you? God damn it. This OB1. OB1 is our main program block, but there are other OBs. OB stands for organizational block. Analog. Working with projects, safety relays. Oh, come on. Calculate function, I already know about that. Program diagnostics. Where is the list? There is a list. Oh, here it is. Page 85. So that's PDF page 87 because everything's offset by 2. Okay. I just wanted to show this list. We have our little OB1, which is for context, the OB blocks are called by the operating system of the industrial controller. So each of the OBs has a different function. So if the operating system encounters something that it wants to tell you, it'll call a certain OB. So for example, the OB1, if there are no errors and everything's working normally, OB1 will be called by the operating system every program cycle. So it'll just eternally, as long as the CPU is running, it'll eternally call OB1 and do what's written in OB1. Then there is also OB100 or OB101, which are the startup blocks. When the operating system boots up, it will call OB100 and OB101, but we will only need OB100. It'll call this guy once. So everything that is programmed in here will be run once when the system boots up. You can also program timers with that. The operating system has obviously has a system clock, and according to that clock, you can call OBs like OB10. In the configuration of the block, you'll tell him run at like 2 p.m. on specifically this date, like run every year on the 6th of June at 10 p.m. And if the system clock shows 6th of June, 10 p.m., this block will be called. And as you can see, you have 7 of those. Or is it 8? 10 to 17 is 8. So you have 8 of those. You can also do a time delay interrupt, which interrupts the program, which runs after a certain time, like it's a timer. You can tell it to run every, let's say, 10 minutes, and every 10 minutes OB20 or OB20 will be called, for example. There's also cyclic interrupt, which essentially does the same. Not really sure what's the difference. I mostly, for timer interrupts, I'll use cyclic mostly, because that one gets repeated. The one that's the one you will use most of the time. Because if you have calculation heavy stuff, like a PID controller for a heating system, which is very calculation intensive, you don't want that to run every program cycle. So you put it into an OB, let's say an OB30, and then it'll only run every minute, once every minute. And since the program cycle is a few milliseconds, that already takes a lot of strain off of the CPU. You can also trigger OB, like OB40 is for if a certain hardware input occurs, like you have an input that, I don't know, is like a special emergency situation, and you need that handled immediately. You can put that onto a normal hardware input, and if that input switches to 1 or 0, can be configured, it'll activate one of these OBs. If the data bus breaks down, or just the internal bus of the CPU with its adjacent modules breaks down, this also has OBs that can be called, like or a programming error. If a value gets called that doesn't exist or something like that, then it will be a programming error, and the operating system can detect that and tell you what that is, and it will write all that information into OB121. So that's basically the gist of the OBs. There is a hierarchy with the OBs, who can interrupt who. Like the lower the number, the lesser the priority is. So OB1 has the lowest priority, and OB121 has the highest priority. The higher the number, the higher the priority, basically. So if let's say OB100 is running and there is a programming error in OB100, then OB121 will interrupt OB100 and execute himself first. Same goes with every other OB, like an OB30 can interrupt an OB10, and the OB10 can interrupt the OB1, and so on. Okay, so much for the theory. Let's create our OB100, our startup OB. Startup. And these are all the OBs the operating system supports. It depends on the age of the CPU and the model you have. Higher performance models and newer models obviously support a lot more stuff. I think there's even one. Yeah, the update one is basically for data bus, data interfaces and stuff. There's a lot of them. You most of the time don't need many of them, but the startup OB is very useful. It can initialize values, just such as the values for the programming counter, but we already handled that in code. If it doesn't work how I did it here in code, I will have to move it into the startup OB. Yeah, we'll see. For now, I have explained so much, I've actually forgotten what I wanted to do. Yes. There is a convention with the OBs. You don't want to write too much code in them. Most of the time, if like an error OB gets called, you just want him to set a flag in your normal program, then the OB1 handles it, because OB1 contains all of the program code. So what we want to do is we want to set a variable. Let's put a set command. This S stands for set it to 1, and we will put here an always true. And I think, what do we call that guy? We need to have a global. Where is my global? Global. Here is my global. I'm getting tired already. The variables in the global data block are just global variables. Just in every other programming language, you can use them anywhere. I'll use him to hold status flags most of the time. Like general flags that get piped into the corresponding data block, program blocks with the code to handle them. Let's have a variable that is called startup. It's a boolean. Or should I not check for direct? I should check for direct startup. That's stupid. I should check for. I'm missing the English word for it actually. Let's pull up my dictionary. I'm searching for the word referenzfahrt. Oh, I hate that translation. The translation is reference run. I don't like that as a variable name. Let's see. Reference. Oh, yeah, let's just call it reference not okay. Reference not okay. Okay. Not okay. Okay. So if we set this variable to 1, then we know that we don't know where we are. We know that we don't know where we are. What a sentence. I love it. So what I want to do is I have another program block that gets triggered when this variable is true. And this variable will be fb reference. Should I go with it? Reference run? Nah, it's okay. Function block reference. And in here we just tell the motors to drive backwards. But the problem is now we have to take the hardware into account. If we just tell the motors to drive backwards, what happens if we are already in our end position? Now what the crane model does, if you trigger the very, very end position, which is a physical switch, it'll just shut off the power to the motors. But we will never detect that, so our program would just be stuck. So what I want to do is I would like to move it forward a little bit and then start moving backwards, just to compensate for that. So let's do that. I think the best way to do that would be with a timer. Not the best way, but the easiest way. Yeah, let's do an off timer. I would like to instance you. You are timer, what do we call that? Reverse, nah. Timer. Let's drink on it. Maybe some fluid will put a thought in my head. Timer. Reverse. I'll just call him Reverse. I'll give him a better name in time. Naming variables is harder than it seems. Let's make everything bigger for readability. Okay, so we have a timer now, and I think what we'll do is we will put him into a temporary variable, x reverse, so I can reuse him. I don't want to have multiple timers. And as an input, I would like to have an option that's called reverse time. And that would be a time variable, so-called time variable, which is in milliseconds. PT should be is that a trigger? Let's call the help. If we are not sure, we call help. Help. Turtle needs help. Okay. I just need to know what PT does. PT is the time it takes for him to turn off. So it's the time input. So our reverse time will go in here. And this is the trigger then, the in. Very good. Now that we have that, I'll define the trigger in time. Let's just build it in like a general setup. I want motors. I will only need the negative of the motors. Can I copy some variables? Can I copy? Yes, I can copy. X-axis negative, Y-axis negative, and Z-axis negative. No, I need all of them because I want to have the reverse. So all 6 of you, get over here. Noise. So let's start with the X-axis. First, I want to drive forward. Then, after that, I want to drive backwards. And backwards will be driven. Backwards should be active until the 0 sensor is activated. I think, oh god, what have I done? Have I done anything? Oh, what happened? Why are you red now? Seems like nothing changed. Nothing changed. Okay. I don't know. TIA portal behavior. Let's go. So we want to have the... It's not the limit switch, because the limit switch is mechanical, but we want to have our... My brain just wants to call it root position. I don't want to call it a root position. Dictionary. I'm using dict.cc as a dictionary, by the way. Home position, that's the value. That's the value. Word. Word is also value. A word is actually 16 bits long. Fun fact. What will it be? It's a boolean if I remember correctly. Home position x-axis. Every axis will have its own home position. And I will write the axis name because this guy doesn't care what is horizontal and what's vertical. It's just free axis that he will home. Because that won't suddenly change with the crane model we have here. So let's just do x-axis, like these. Oh, you're all time now. Don't want to have you in time. Want to have you now. So as long as this guy is, if I'll invert it, if he turns from a 0 to 1, so if he gets activated, he will stop the motor. Very good. And reverse is not active. Yes. As long as the home center is not active and the reverse function is not active, the motor is allowed to turn backwards. If here this one is only activated by the reverse function. And I would like to add a little safety here. Because if I start to home the X and Z axis, when the Y axis is inside the storage, I'll just rip out the storage shelf. And I would not like that. So the first axis we actually have to look at is the Y axis, because the Y axis is our fork. Why are you yellow? Because you are an input, because I am stupid. This is my output. Y-axis. Very good. It's not good practice to read in output, to write to outputs, or to read from write into inputs, or to read from outputs. Complicated sentence. Very complicated. You know what? The start can also just be called start. Start. And I'll have that done and dusted. Very good. Okay, now the y-axis is the first one to to go. So he can have this logic. He'll move a little bit forward and then start moving backwards until his home position is reached. Now for the other axis, I will copy these networks here, but I will add something to them. For the the X and the Z axis can move at the same time. That's no danger at all. But there needs to be a little AND gate here. And oh, that's weird now. I'll come to it. This one needs to be true. Yes. So our condition. Oh. Home position. Oh, yeah, I just took the wrong. I still have the old input here. I'll explain in a second. Give me a moment. Give me one more moment. I am stupiding. I'm fucking it up right now. Okay. So what I'm planning to do here is the y-axis moves backwards, and as soon as the home position sensor on the y-axis activates, I know it's out of the storage shelf, so I can start my x and z axis. Oh, I have just the x-axis here. So reverse will be true, and the home position y-axis will be true, so he's allowed to move. Same down here. I'll move that around a bit though. I don't want him at the bottom. I'm quite stingy with the order I have variables in, because it confuses me. If I have it in an order that feels weird to me, I get confused very easily. I'm a person that is confused very easily. Okay, now now we have a little problem, because this timer here, it'll start once. But the only axis that moves at first is the y-axis. So at the moment the y-axis gets into home position, the timer will already have advanced. It'll already have reached its end. So we need to restart it. I still would like to just have one timer. So we need to re-trigger it. So what I'm gonna do is I have an OR. I have an OR gate here, and I need to make this an impulse. I don't have to have the OR here. The TOF timer is a time off, so it starts counting as soon as its input switches from a 1 to a 0. So I only want that to be a trigger, so that it's only an impulse that is one program cycle long. Let's see. I think these are under our normal rising trigger. Please instance that. It's the rtrig reverse timer. For the reverse timer, and that will be instanced in our data block, and that's right in here. And here we want to have our OR, and it can either be triggered by the start, by our start variable, or the home sensor of the y-axis. He will output an impulse if his CLK input switches from a 0 to a 1. And it can either do that if the start input is there, or if the home position is there. If the home position gets activated. I'm just thinking, what happens if the start signal stays on? Then this guy can't trigger again. So I would have to copy this whole setup. This is rtrig x start then, and the other one would be rtrig home y. Because he will only detect the switch from 0 to 1. So if the start input will stay 1 for the whole duration of the reference run, of the homing run, he cannot trigger again. So if this one stays true and this one gets activated, it'll not do anything, and the whole process will never continue. So let's fix that with a second trigger. You go and you go too. Yes, like that. And both of those will output into our timer with rtrig x start dot q. I can just read out the q output with this syntax dot q. Okay, and now if any of these get triggered, the timer restarts again. But the y-axis won't move because the home sensor is already active. Do I like that though? Yeah, maybe I'll expand it a little bit to have a little bit more nuance, but for now it should be good enough. Let's copy that over for the z-axis as well. You have y-axis, yeah, home y-axis, and x reverse triggers you, and home y-axis reverse if that is not active, but you are looking for home z-axis, and I will also have to change the outputs. We won't be needing the collection network that collects internal variables and writes to the output, because every output is only used once. Yes, that should work. It gets enabled by that. But it would be disabled by... No, that's good. That should work. Okay. Let's close everything up here by putting the manual mode is on top, then the encoders, and below. I just deleted that. Oops. My mouse aim today is shit. And we put in the reference data block as well, the reference program block. So we will need to add a new input in our collection down here. I like to keep it in the order that I have the blocks in, so let's do that. Let's add some temporary variables. Or I think the reference is very similar to the manual, so I copy that and modify the names again. You are not manual moder now, you are reference moder. And I would like to rename you reference. Might look a bit excessive that I do it like that, but I have my reasons from last semester project where I had a great deal of difficulty to deal with all the outputs that are written to at multiple times in the program. Like I had the same the problem that I was writing to an output, but I used it somewhere else too, and so it got overwritten and yada yada yada, which was really annoying in the end. And the program, as I said multiple times, it did not work, sadly. That's also why I'm starting from scratch again this time around. Sneezed. Wow. Something triggered my nose really badly. I was changing the tires on my car today, and I don't know why, because it's already autumn, but something triggered my nose really, really hard, and I had a sneezing fit. Like a really bad one. Yeah. Okay. We have start, reverse time, home sensor. Yes, home sensors. These are physical ones, so they are in our variable table down here. In here. Let's see, where are they? Here, I, X, and switch. And I would like to have the one from negative X, the one from negative Y, and the one from negative Z. Wonderful. That's how I like it. I'm thinking thoughts, thinking slowly. Now for the reference, our starting condition is our reference not okay. That's when we want to start. Why are you red? Because you are the wrong data type. You need to be a Boolean. And what we also need to do, we will need to disable the... How's it going? I'm making progress. Brain running hot. But we have made the automatic mode is basically finished, and we are working on the homing position so that the crane can automatically determine where his home position is. That's what we do right now. So if we know our position is not okay, the automatic mode needs to be disabled. We are not allowed to go. So the not okay variable needs to be 0. We negate that. and then it will be 1 in this AND gate. So if everything is okay, it will be 0. We negate that to a 1, it will be okay inside here. So we can start the automatic mode. I think I'm starting to confuse myself. Well, no program worked that the first time, I guess. Not even mine do. Probably. We'll see. Yeah. Okay. Let's continue. Next. What needs doing? What needs doing in here? We have our reference. We still need to define our reference time. That can be a global variable though. It's a time variable, isn't it? So it's t for time. It's time. What did I call it? I called it reverse time. T reference homing reverse time. And you're a time variable, so you need to be also the data type. Data type time. That's probably one that doesn't really exist outside of PLC of Siemens controller programming. It's just like a pre-made special variable that's just used for time stuff. So the system itself already knows that it's a number that's representing milliseconds. And that populates everything in here. Are you all... Yes, you are all user-defined variables. I'll leave them. I'll leave these guys for later because they are a bit special. I'll have to put them in a special place. Technically, I would have to do that with this guy as well. I'll get to that. But to get to that, I'll delete him again because otherwise I'll be confused. Okay, now back to our startup OB. As we can see, we have our not okay variable now. And what we will do is we will set it to not okay when we start up. And after we completed our reference searching, reference okay will be our output variable. Now we update you. Now we have another output down here. And this one, what we do with this one is we take set, where is it? Let's just take you. And we will reset it. We need to have a little value in between, variable in between here, x reference. I'll just call that x reference, reference. Because I can't connect this guy directly to the output for reasons. It's the portal. You don't ask. It just is. So that means when the PLC starts up, it'll set the reference to not okay. This will trigger the. It will block the automatic mode and trigger the our homing run. When the homing run finishes, it'll reset the reference not okay variable to 0, which will enable the automatic mode again. Very neat stuff. We don't need to set it when we go into manual mode because the encoders here will always run. Even if you're in manual or in automatic, doesn't matter. They will always do their job of recalculating the position, no matter who's moving, the system itself or the user. I'll pull that stuff up a bit so we have a better structure. Now the encoders are on top, the reference right below, then comes the manual mode, and at the very bottom is automatic. So that means the encoders will always be evaluated first. And my bag just fell over. Ghosts, stop throwing around my bag, please. I'm not superstitious. But who knows? Okay. No, it's already 9:20. Let's see how long I'll go. Probably not longer than 10. Because 3 hours straight of programming gets to me. my brain's mush in the end. And I will have a little announcement at the end of the stream. How I'm proceeding this week with the streaming schedule, basically. But I'll get to that I think at around the 45, when it's 15 minutes before 10, somewhere around then. Okay. Let's see what needs doing. Let's see what needs doing. What needs doing? We have our startup here. Now what I wanted to look at is something in here. Automatic mode. Something I have not really taken into consideration. What happens if the system is turned off in the middle of executing, like in the middle of positioning here, for example? I don't have a good way of resetting the counter. I don't have a way of resetting the counter then, because the counter will only reset itself when it reaches 5, well, when it reaches the end of the program chain. But it will also need to reset itself when the CPU starts up. Now, I could do that in our startup OB. That's what he is commonly used for. But I have a better idea than that. I put in here an OR. And there is... No, that doesn't work. There is a variable that it's called first scan. Here, this variable is true at the very first program cycle. Then this is true. Otherwise it isn't. Now, the problem with that is, what happens? No, that works. Because what I was thinking is, if the program block is not called on the very first scan, it will not be reset. But I am not disabling any of these. The program blocks get called. The only way to not call one of these blocks is if I have something on this pin that sets the enable signal to 0, but I have never connected that, so that enable signal is always 1, so they will always be executed. So that should work. So I just put in this at all the other times I have made a programming counter, and I think that's, is it? Did I take one in here? No, I did not. But with the loading and unloading, I made that as well. So that means an OR and the first scan. Loading one needs one, the unloading one needs also one. Yes. First scan. Very nice. So now we have the startup of the PLC handle. If the PLC starts up fresh, it'll reset the program counters of the automatic mode, the loading code, and the unloading code. The positioning code doesn't have a program counter, so that it doesn't matter there. Does reference have one? I don't think. No, he doesn't. And now that I think about the program counter, I think I forgot to put the incrementing. No, I did. I put it in. I thought I forgot this part down here that increments the program counter, but no, I did. I put it in. It's okay. It's very good. But I forgot it in the automatic block. So let's make a copy of the one I used in here and take it outside for a walk and paste it in here. Let's make you bigger. Can I make you bigger? Yes, I can. You're bigger. So let's add that stuff too. I need to take out the step the triggers for the step creation. That. Let's put you up here where all of the others are. That. In post loading will increment you. And that's already everything. Let's take him down here. This is step 3? Yes, it is step 3. That's so it stays synced up. Need to update you. Now I need to just update everything here so it actually counts correctly. X loaded. Now we copy it once more. We do that 5 times for every program step. Get you in here, change this to a 4, change the trigger variable. Yes. And now we make another copy. Oh god, that's the copy on the wrong place. Needs to go one down. Perfect. Copy you and paste you here. And that's why I needed the different That's also why I needed different variables to start the next program block. And that's why I renamed XInPos to XInPos unloading and loading. That's also part of the reason. You need to get here. Step 5.q unloaded, and that should be everything. That should be good. save that. Your portal doesn't save by itself. How dare it? 2. Very good. Very, very good. Yes, I am happy with that. We are getting quite close to testing that stuff. I'm not sure if I should do a basic visual first, or if I should just test it out of one of the data blocks. Like I use a data block as a very crude interface. I'll have to decide on that. We'll see. I'm not really planning the streams out like I'm gonna do this, I'm gonna do that. I'm just doing. That's why I sometimes look around like what needs doing, because I don't know myself. Yes, this guy is out now. I can just compile it and he gets updated anyway. At least he should be. He doesn't? How dare you? Oh god, why are you not? Update. When I add something in the in and outputs, it needs to be the data block itself needs to be updated. And sometimes it does that automatically and sometimes it doesn't. It's a bit inconsistent. Okay. So let's go over it. We have the encoders, homing position finder, reference, yeah. We have a manual mode, we have an automatic mode. That maybe works, it's untested as of now. Now yes, what I can do as a trigger for the start is we either want this guy to be in manual mode or in automatic mode. So we just take the same switch. This is a physical switch on the front of the model. So if this button is pressed, if it's activated, it will trigger manual mode, and if it's deactivated, it'll trigger automatic mode. And that should work. We'll see. It'll get a little bit more sophisticated once the touch panel comes into play, because then he will I'll probably redo this input here to be on the panel itself. We'll see. Maybe I'll keep both of it around, but that'll just make it more complex. Decisions. So many decisions. That'll probably haunt you in the end. Yeah. What needs doing actually? Oh, I know. I'll switch to the camera real quick. On the bottom left, well, on the bottom of the crane model, there are the little buttons. I'll point out the one I mean in a sec. 1 second. The big one. The big one is an emergency stop. So it needs to be handled, because the teacher already let's say promised us that he'll just press that thing at random. So if my program can't handle that, I'll probably get there will probably be great deductions. Because in real life it's the same. You have to you have to be able to push that thing, and then the machine can't just finish the cycle. If someone has his hand in there and you press that button, that thing needs to stop now. But you know what? That will be adding some inputs at certain points in the program that just reset it and trigger and will probably trigger a reference. But I'm really done for today. I've done a lot of physical stuff. Like I said, I've changed my tires, I've done laundry and everything. So I'll probably start calling it a day a little bit earlier than usual. What I wanted to announce is the fact I'll be rebuilding my PC over the next 2 days. So if everything goes well, I may be able to stream again on Wednesday, but I'm not sure because I also have a test, pneumatics, on Friday, I think. Phone, is it Friday? Is it Friday? I have school on Friday and Saturday. Oh no, it's on Saturday. I have a pneumatics test on Saturday, and I have to put together a little knowledge base for that, so I can look up. So I learn the material and have a little lookup sheet for the stuff that is in the test. So streaming will probably be reduced this week. If I stream, I'll put it in the stream calendar, like the schedule thingy on Twitch. But in any case, it would either be Wednesday or Thursday, depending how fast I am with the pneumatic stuff and my PC rebuilding. Yeah. So thanks everyone for coming, for watching again, doing my boring project. Wink wink. And yeah, see you all next time, either Wednesday or Thursday.